Hi class, we want to continue our study in chapter 4 talking about triangles and congruence. And what we want to do is we want to move into section 4.4. And this is talking about congruent triangles by ASA and AAS. So ASA stands for angle, side, angle, and this stands for angle, angle, side. So what this is going to be proving two triangles are congruent using these two methods. And these methods are going to be a lot like the side, 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 and side, angle, side from the previous section. So the last thing we're going to do, our second objective, is we're going to identify when to use the side, 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 angle, or angle, angle, side to prove triangles are congruent. All right, let's start with the angle, side, angle postulate. So if two angles and the included side of one triangle are congruent, so what I mean by that is if you have two angles and the side included between them like this, all right, are congruent to the two angles and the side of another triangle, then the two triangles are congruent. So if angle A is congruent to angle D, side AC is congruent to side DF, all right, and angle C is congruent to angle F, then what we can say is triangle ABC is congruent to triangle DEF. All right, so let's look at these, all right, and choose two triangles that are congruent by angle, side, angle postulate and explain why. All right, well, look here. Remember the angle, side, angle, we want two angles and then the side included between them. So if you look here, I've got two angles, but I don't have the side included in them. I have two angles, I don't have the side included in them. Here I have two angles and I have the side included. And over here I have two angles and the side included. So it must be here that choices B and D are congruent by angle, side, angle, because for these two triangles, the sides marked congruent are the included sides of the two congruent angles, like I said. All right, another one, the angle, angle, side theorem. Right? If two angles and the non-included side of a triangle are congruent, so like over here, I have angles A and angles B and angles D and E congruent, all right, but not the included side. I have a side that's not included to it, all right, are congruent to two angles in the corresponding non-included side of another triangle, then the triangles are also congruent. So like I said, if angle A is congruent to angle D, angle B is congruent to angle E, and AC and DF, which are not the included side, right? So then I have angle, angle, side. I could say that triangle ABC is congruent to triangle DEF. All right, so let's do a theorem here. So let's talk about proving triangles are congruent. So I want to say I've got this shape here, and ray DB bisects angle ABC, right? So it bisects this angle, and angle 1 is congruent to angle 2. So I want to prove that triangle DAB, this side, is congruent to triangle DCB, this triangle. All right, so to do this, we're going to have to do a two-column proof. So first off starts what's given, all right? Ray DB bisects angle ABC. What that means then, all right, by the definition of an angle bisector, is that angle 3 is congruent to angle 4, all right? So that's the definition of an angle bisector. Next, we were given that angle 1 is congruent to angle 2, all right? That was given. So see what I've got here. I've got this angle and this angle are congruent to this angle and this angle. So I've got two angles here, all right, on each side that are congruent. Well, these triangles share a common side. So side DB is congruent to side DB. That's that reflective property, which we've used a bunch in this section. So I've got angle, side, angle congruent to angle, side, angle. So it must be then that triangle DAB is congruent to triangle DCB by that angle, side, angle postulate. All right, great. Let's do another one, all right? For this two shapes here, or this shape here, what you see is it forms two triangles. What we're saying here is that angle B and angle E are right angles. C is the midpoint, okay, that's important, of this segment here, AD. So what I want to do is I want to prove that triangle ABC is congruent to triangle DEC. All right, let's go through it. So first off, we're given that angles B and E are right angles. That's given. Well, if they're right angles, then angle B must be congruent to angle E. All right, that's the definition of a right angle. So look what we're doing here. We're starting by saying these two angles are congruent. The next thing here, look at this. We have this segment, and what we're saying is C is the midpoint. So we're saying C is the midpoint of AD. All right, that was given. Then what it must be is that AC, this segment here, must be congruent to segment CD here. And that's just by the definition of a midpoint. So now I've got this angle congruent to this angle, this side congruent to this side. Well, look here. I have angles 1 and 2. Well, they must be congruent. Why? Because of the verticals angle theorem. So listen to how I say this. I have an angle, and a side. I have an angle, and a side congruent. Well, triangle ABC must then be congruent to DEC because of the angle side theorem. All right, so let's just talk about setting these up. So for each pair of triangles here, say whether they're congruent by side, 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 angle, or angle, side. All right, so let's identify the postulator theorem that confirms this. All right, so A here, it looks like I've got three sides that are congruent. So for A here, it looks like this is side, side, side to prove they're congruent. Angle, side, angle, side. It's not the included one here. It's not angle, side, angle. So it's angle, side. So we would prove these two triangles are congruent by angle, side. Look over here. Angle, side, angle side, angle in a row like that. We would prove those two by angle, side, angle. Now this is weird. You're only given that this side and this side are congruent to this side and this side. Well, what you notice here is right across here, we have two vertical angles, so they must be congruent. So it looks like it would be side, angle, side, angle, side. So your goal here is just to look at the triangles and identify which theorem you were going to be using.